We're back with another gas Sudoku by full deck and missing a few cards. This one is called Boxed Out, and the rules are as follows. You've got X's, which indicate that the pair of adjacent squares sum to 10, like Roman numerals. Similarly, V's sum to 5. You have killer cages, which mean that these cages, bounded by those dashed lines, sum to the number in the top left, 18 there. And digits can't be repeated in cages. They couldn't repeat here anyway, because they're each in individual boxes, but nonetheless, they couldn't repeat even if they didn't. And I think that's all it is to it. Regular Sudoku rules apply, and the link's in the description. And I'm going to restart for my timer. Okay, so first things first, these can be made of 1-4 pairs and 2-3 pairs. And similarly here. And similarly here. Given we have a low digit for sure, then this has to be 9, 8, 7, 6 to make that 10 sum. You can't have 5s on a 10 sum, you'd need 2 of them. We can do some more 1, 2, 3, 4-ing. And some more 6, 7, 8, 9-ing. It actually looks like we can do that all the way around. I'll start with that. Okay. Next then, we can see this is an X, and we know that one of the digits is low, so the other must be high. They couldn't both be low, otherwise we wouldn't hit the target sum. So that's 6, 7, 8, 9. And we have this nice ring completed, which is great. What can we do with it? Well, I think it'll help to actually highlight low numbers and high numbers. Generally is a helpful strategy. I can see that we have a couple of quadruples. Let's go pink, and oops, we're not on the multi-select. Blue. Pink and blue. We can see that this forms a quadruple, so does this, and so does this, and so does this. We actually have four quadruples. So 5, 6, 7, 8 and 9 must lie in those 5 squares. What about these sums? Is that restrictive? Clearly this couldn't be a 9 and a 4. Or even more so, this couldn't be a 9 and a 4, or an 8 and a 4. It could be a 9 and a 1 and a 2. No, it couldn't. So both of these digits need to be at least 5. So the sum there is 12. Since this is a quadruple and this is a quadruple, there's no 1, 2, 3, 4 in either of these two squares, meaning these are at least 5, and they can't both be 5. So we have to have at least a 5, 6 between them. And 5 plus 6 gives us 11, which actually forces us to be a 1. So this is the minimal case for these two squares. Anything larger would render this unfillable, and this renders it with a unique solution. And I think that's going to be lovely, because we can just totally enjoy these X's and V's to our heart's content, at least in this corner. Right, that does solve the parity there too. We have lots of things to eliminate, lots of red marks. Okay. Looking at this, we know we've got a 2 and a 3 in the top one, so a 1 on the bottom won't make a 5 ever. So we know that's 2 and 3. Similarly now, 2 and 3 added to 9 won't make a 10. So we've actually eliminated down this corner to a 2, 3, 7, 8 situation. Without even looking at that killer bracket, that's a pair, which means this itself couldn't be 2, 3. And we've got like a rotationally symmetric position. That is, sorry. No, that's good. Oh, and since this couldn't be a 9, we know it's parity. Lovely. And we've got some more eliminations to happen here. This can't be a 9, it can't be a 6 either. And the rest is set, that's okay. Then let's have a look at this. This is a 13 cage of these 3 digits in. At the worst case, or the best case rather, to find the minimal solution for the pink value, we'd take 2. And the remaining 2 digits have to be, again, at least 5 and 6 respectively, because we have these quadruples. 5 and 6 with that 2 actually fill it to the perfect 13 that we need, so we can go ahead and write those in. Pardon. And this 8 fixes the other corner, so we have a nice ring to work off of. This is very symmetric and very satisfying. Let's perhaps look at these high digits here. So we know neither of these can be low, they have to be high. This one is limited to 8, 9, and this one is limited to 5, 9. And we need to make a sum of 16 between them. Oh, this is actually limited to 5, 7, 9. That's important. So we need 16 between them, and I think the only way to do that is with 9 and 7. Otherwise we need 2 8s. It's not possible even if the top digit wasn't seeing an 8. This is the only way we can. And the last digit will sum to 14, again containing 5s and higher. So this can be only 5. This can be only 9. And perfect. That's what we wanted. Right. I suspect we could move to the inside square now with so many of these constraints. Just by Sudoku we need a 2 here, we need a 3 here. That's very limiting on this square. This makes this a 19 cage. Taking that 2 out, we've got a 17 cage made up of 2 digits. In fact, it's too limiting, that's a mistake. It can't be 2. We'd need a 9 and an 8, and we can't have a 9 in there. Right, well, that's because 2 can go in the middle row, can't it? See, we're going to have to be careful here. So we can talk about 1 and 4. I just assumed that we'd had 2s on the tops and bottoms. Right, so we can talk about 1 and 4 on this side being somewhere in the middle row. And using that same information, we can eliminate 2 places for each of them, and I expect we're going to get a symmetrical pattern. So 2 can go in either of those, and 3 can go in either of those. Yes. What about the high digits? There's less of those, so we should be less constrained. But we do have them in the middle row and column. So each of the high digits, I believe, is constrained to 4 squares. And none of them are forced to be in one of the cages. Okay, looking at this 19 cage, it's still restrictive. It has to contain either a 2 or a 4 in it. If it contained none of those numbers, then 1, 2, 3, 4 would have to fit in those 3 squares. So, looking at those, can it contain a 2? My blunder earlier told us that it couldn't, because we need a 9 and a 7 in these 2 squares, and this C's a 9, so clearly that can't work. Hence this has to be 4, and this can't be 2 anymore, because we wouldn't be able to reach the total sum, meaning the middle block has to be 2. And we actually have 1 and 3 fixed now. This is great. We should be away at this point. We can continue with Sudoku, or we can keep looking at the puzzle in its intended form. Let's do that. That top cage of 19 now is a 15 cage. 15 can be done with 7, 8 or 9, 6. This 7 rules out the first, so it has to be the latter, and that's going to be 9 and 6. The 8 is forced here, and that puts a 5 here. So we've got our first completed box. Following that up, we can hopefully complete a bit more. This is going to be 5 and 9 in some order, but I think we can't say the order over here. We can write them in. Oh, of course we can. Should have seen that by the symmetry alone, but nevertheless. Left in here we need a 6 and a 4, which we can place. And so here should we be able to place a 1 and a 5. Lovely. Now if we move to the rotationally symmetric part, we should do the same thing. Perhaps starting on rows 4 and 6. Row 6 needs an 8 and a 6. No, a 6 and a 9 instead. There's a very forced. And row 4 needs a 2 and a 5. Less forced, but still forced. Box 6 needs a 3 and a 7. And box 4 needs a 5 and an 8. And now we just have these corners to go. And what can we use? I'll just start writing the kind of restrictions. Perhaps row 3 and 7 are best. Column 3 and 7, row 3 and 7. I don't think they actually immediately offer anything in row 3. Just a pair, which is better than a boot. So let's put those in. This one does give us something. This breaks the symmetry at last. It's 8 and 9, but 9 can't go here. And I'd expect that symmetric pattern to hold, so that one of these gives us a digit, the other doesn't. Or perhaps they'll just all give us digits now that we've added that extra information in. Yeah, that was forced, even if we hadn't done the rows. 6 and 8. 6 and 8. And now we just have these boxes to consider. Let's consider them as boxes. 2 is limited to these. 3 is limited to these. I should really write this in, shouldn't I? Are we going to get something cyclic? A 4 cycle. 4 can be anywhere. Right. Well, that won't be symmetric. And 8 is very restricted. 8 has to go here, and we can unwind it all. We even get some confetti. How nice. How thoughtful. This row gives us 2 and 4. Not 2 and 4. Take your time. 1 and 2, and we can't place those. And that leaves us with 5 and 4 here. And we can place those. Okay, 1 and 2 are still up for grabs in the top box. 2 can go here, 1 can go in any of them. 3 can go in any of them, except not the right ones. And the last digit should fix everything. It's a 6, which does fix everything. And now to finish off our wonderful puzzle, boxed out by full deck and missing a few cards, we have 1 in row 1, column 1. We have 3 in row 1, column 2. We have 4 in row 2, column 2. 7 here, and the last 1, 2 pair resolution. Great, a lovely, symmetric, happy puzzle.